The North Atlantic Ocean is an engine, not a metaphor, an actual heat engine that moves more energy every second than every power plant on Earth combined. It pulls warm tropical water northward along the surface, releases heat into the atmosphere over Europe, then sinks into the deep ocean and flows back south along the seafloor. This loop has been running without interruption for roughly 12,000 years. It is the reason London, at the same latitude as Calgary, has palm trees instead of permafrost. It is the reason Northern Europe can grow crops. It is the reason the entire North Atlantic Basin functions as a single integrated climate system. And right now, in July of 2026, the engine is showing signs of stalling that scientists have never observed before. The system has a name. It is called the Atlantic Meridional Overturning Circulation, or AMOC. The name is technical. What it describes is not. Warm, salty water from the tropics flows north along the surface of the Atlantic, passing the eastern seaboard of the United States, then arcing across toward northern Europe. As it reaches the cold latitudes near Greenland and Iceland, the water releases its heat into the atmosphere. That heat is what keeps European winters mild. Once the water cools, it becomes denser. It sinks. It plunges to the bottom of the ocean and begins the long journey south, completing the loop. The sinking is the critical part. It is the pump that drives the entire system. If the pump weakens, the whole circulation slows. If the pump fails, the circulation stops. The pump runs on salt. Cold water sinks because it is dense, but the density of seawater depends as much on salinity as it does on temperature. The water arriving near Greenland is not just cold. It is salty. That saltiness is what makes it heavy enough to sink. And that saltiness is now being diluted. The Greenland ice sheet is melting at a rate that has doubled in the past 2 decades and accelerated sharply in the last 3 years alone. In the summer of 2026, satellite measurements show surface melt across 60% of the ice sheet, an area larger than Mexico, during a single week in July. The meltwater is fresh. It pours off the ice in rivers that carve channels through the glacier surface, then plunge down into the depths through crevasses and moulins. That fresh water flows into the North Atlantic. It is lighter than the surrounding salt water. It floats. It forms a lens of freshness at the surface that acts like a lid, preventing the warm salty water beneath from releasing its heat and sinking. The pump is being choked off at the source. The last time the AMOC shut down, the world was emerging from the last ice age. Roughly 12,000 years ago, a massive glacial lake in North America burst through its ice dam and emptied an entire inland sea of fresh water into the North Atlantic in a matter of months. The AMOC stalled. The northern hemisphere plunged back into near-glacial conditions for 1,000 years. Temperatures in Greenland dropped by 10 degrees Celsius in a single decade. Forests that had been recolonizing Europe retreated. The monsoon across Africa and Asia collapsed. The event is called the Younger Dryas. It is not a theory. It is written in ice cores, ocean sediments, and the fossil record. The amount of fresh water entering the North Atlantic from Greenland right now is not yet as large as the Younger Dryas flood. But it is accelerating faster than any previous melt event in the geological record. What scientists are seeing in 2026 is not a full shutdown. Not yet. What they are seeing is a measurable, sustained weakening of the circulation. Oceanographic moorings deployed across the Atlantic at 26 degrees north, a line stretching from Florida to Africa, have been monitoring the volume of water transported by the AMOC since 2004. The data shows that the circulation has weakened by approximately 15% over 2 decades. But the decline is not linear. In the past 3 years, the weakening has accelerated sharply. The flow is now at its weakest point in more than 1,000 years, according to proxy reconstructions. It is not a gradual trend anymore. It is a pattern break. The immediate effects are already visible. A persistent cold blob has formed in the North Atlantic just south of Greenland. It is the only region on the entire planet that is cooling while the rest of the world warms. Satellite sea surface temperature maps show a distinct patch of blue in a sea of red. The cold blob is exactly where the climate models predicted cooling would appear if the AMOC began to falter. Less warm water reaching the region means less heat released into the atmosphere. The cold spot is not a temporary anomaly. It has been present and growing for years. Meanwhile, the water that should be sinking is piling up. Sea levels along the U.S. East Coast from North Carolina to Florida are rising faster than the global average, roughly 3 times faster in some locations. This is a direct consequence of the AMOC slowdown. When the current weakens, the northward flow of water at the surface slackens, and water piles up on the western side of the Atlantic basin. Coastal communities from Miami to Charleston to Norfolk are experiencing more frequent sunny day flooding not because of melting ice alone, but because the ocean circulation that normally pulls water away from the coast is faltering. But the consequence that has scientists most alarmed is not the cold blob. It is not the sea level rise. It is what happens to the tropical Atlantic when the northward heat transport slows down. The heat that the AMOC normally carries northward stays in the tropics instead. The waters of the tropical Atlantic, already at record high temperatures in 2026, become supercharged with energy they cannot shed. This energy does not sit idle. It feeds hurricanes. The 2026 Atlantic hurricane season is already forecast to be extreme. The sea surface temperatures in the main development region between Africa and the Caribbean are running hot enough to support rapid intensification of any storm that enters the basin. When Hurricane Beryl exploded from a tropical depression to a Category 4 hurricane in 48 hours earlier this season, forecasters called it unprecedented. The ocean conditions that made it possible are still in place. They are intensifying. The interconnectedness is what makes the AMOC so critical. A slowdown does not just cool Europe. It shifts the tropical rain belts. It weakens the monsoon in West Africa and India. It pushes more heat into the southern hemisphere. It redistributes carbon uptake by the ocean. It alters the jet stream over the North Atlantic, which in turn affects storm tracks across Europe and North America. A single weakening current pulls on threads that reach every continent. The question scientists cannot answer is whether the current weakening is a temporary fluctuation or the beginning of a collapse. Climate models have long suggested that the AMOC has a tipping point, a threshold of freshwater input beyond which the circulation cannot recover and shuts down irreversibly on human timescales. The models disagree on where exactly that threshold lies. What they agree on is that the system can flip rapidly once the threshold is crossed. Not over centuries, over decades, perhaps faster. The sediment records from past AMOC disruptions show that the transition from a strong circulation to a weak state can happen in as little as 10 years once the tipping point is reached. The ice is still melting. The freshwater lens is still growing. The pump is still slowing. The North Atlantic Ocean right now is not normal. It is doing something it has not done since the end of the last ice age. The engine that has kept the Northern Hemisphere stable for 12,000 years is running rough. Whether it stalls depends on how much more fresh water enters the system and how fast. Greenland is answering that question with every summer that breaks new records. The rest of us will learn the answer in real time. We are watching. Subscribe if you want to know what happens next.